What's poppin', dogs? Mr. Allen here with some solving of trig functions that involve our double angle formulas you see up top there. So we got to solve for theta when it's bounded between 0 and 2 pi radians and when it's unbounded. Okay, so they'll ask you different ways of writing answers on your test. Be prepared for both. I got you. Cosine of 2 theta plus cosine of theta equals 0. I can't factor out a cosine. This is not cosine squared theta. Otherwise, I could. So I got to use my cosine double angle formula to rewrite this thing to allow me to solve it. Pretty sure I don't want to add a sine squared in the mix here. That's not going to help me. But there are two other forms of our cosine double angle formula, which we can get by using our Pythagorean identities and substituting that in. What we'd get for this one, either memorize it or know how to get it, is it's going to be 2 cosine squared theta minus 1. So I can replace this with 2 cosine squared theta minus 1. Then we still have our plus cosine theta equals 0. I'm going to rewrite this in standard form because it's a quadratic we're dealing with. We're going to do some factoring here in a sec. Love me some factoring. Plus cosine theta minus 1 equals 0. You can choose to replace these with like a u or an x or whatever, so you can factor it and not write cosine over and over. I'll keep with the cosine here, but you can always rewrite that. Some teachers will favor that, whatevs. So I'm going to guess and check this thing. Okay, I'm not going to do rainbow method. Some people do that. It's a lot of steps. You already got a lot of steps in here, so we got to cut some steps somewhere. The only way I can get 2 cosine squared theta is if I have 2 cosine theta and cosine theta. It's the only way to get it. The only way to get negative 1 is by doing 1 times 1 with one of them being negative. So I know it's going to be 1 here and 1 here, but which one needs to be negative? Since this is plus cosine theta, I got to have the 2 cosine theta times 1 being the positive 1 and the 1 cosine theta being the negative, so that we have 2 minus 1 gives me 1. This checks out. We're ready to rock and roll. I'm going to set each factor equal to 0, so I got 2 cosine theta minus 1 equals 0, and here I have cosine of theta plus 1 equals 0. So I'll get cosine of theta equals 1/2, and cosine, of theta equals negative 1. It's fun. It's like you get like multiple problems in one, right? It's not just, just 2 cosine of theta minus 1 equals 0, solve it. I break this apart, man. This is dope math, right? We get double the fun here. So when is cosine of theta equal to 1/2? Well, that would be at pi over 3, right? So theta equals pi over 3. And it's also going to be in the fourth quadrant, so that'd be 5 pi over 3. You may need to draw triangles. I like to draw triangles in my head. So the triangle that I had in my mind, since you can't read my mind, I think I could pop it up here. I was drawing it out as a 30, 60, 90, right? So this is a root 3 over here, a 1 right here, and a 2 right here. So that would be my adjacent over hypotenuse is 1 over 2. Cosine, boom, pi over 3, okay? And then I position it down in the fourth quadrant because cosine is positive there. But I'm drawing triangles in my head. Some people memorize the unit circle. Whatever you want to do, right? It's up to you. As long as you can get the right answer, that's, there's a few ways to get there. Next part here, we got cosine of theta equals negative 1. So when does cosine equal negative 1? Well, that's my x coordinate. I'll use this guy since I have it up here. My x coordinate is negative 1 over here at pi, right? That one is negative 1 comma 0. So we're also going to have pi in the mix. So those are my 3 answers when it is bounded between 0 and 2 pi. So what's this unbounded business? Well, this unbounded business is that I would have it from negative infinity to infinity. So I'm going to take this answer and I'm going to give myself a coterminal, right? So I would add 2 pi to it, and then that would give me another solution, right? Because it would land in the same spot. And then if I add 2 pi again, I'd land in the same spot. And if I do it again, I'd land in the same spot. In other words, we can just add 2 pi to each one of these, and we Gucci. So we got theta is going to equal pi over 3 plus 2 pi. But how do I add 2 pi over and over and over again? We'll say 2 pi n. There we go. So that n is some integer n. We usually define it as that, okay? And then we would also have the 5 pi over 3 plus 2 pi n. And then we have the pi plus 2 pi n. Now, sometimes there's an easier way or a cleaner way to write this, but the issue here with this one, I'm going to draw up this other triangle here, is that I don't have a way to get from this one to this one here and then add the same thing to keep rotating. You know what I mean? But maybe, hold up, now that I'm looking at this, let's see if we could. So this is acceptable, okay? This is acceptable. But maybe there's a cleaner way of writing this. Check it out. My other answer, so I got my answer over here, right? I got my answer right here, and I got my answer over here. Let's rewrite pi as 3 pi over 3. Okay? So we're at pi over 3, 3 pi over 3, and 5 pi over 3. Those are all 2 pi over 3 apart, aren't they? They are, right? So if I actually did this is the quickest way of writing it. If you think of it, like this is usually acceptable, unless your teacher specifies otherwise. If I did pi over 3 plus 2 pi over 3n, would that work? If I plug 0 in for n, I get pi over 3. If I plug 1 in for n, I get 1 plus 2 is 3 pi over 3, which is pi. And if I plug 2 in, I'm going to get 4 pi over 3 plus 1 pi over 3 gives me 5 pi, and it would continue on that path over and over and over again. If I plugged 3 in here, I'd get 6 pi over 3. That's 7 pi over 3, which would land me right back on this first one here. Oh my goodness. We just crushed that, guys. We just crushed it. Boom. That's beautiful, man. All right, so that is the cleanest way to write that unbounded, but this works too, okay? So a lot of people just go down to the, oh, I'll just add 2 pi n, but like this is a little more gangster right here, right? You put some thought to it. You're like, no, I got this. I can write this in one easy way, right? Whatever you want to do. All right. Unless your teacher's like, you have to write it like the cleanest way possible, then you would have to do that. But they might not. I don't know. I'm going to move on now. Okay, I'm going to move on. That was a lot there. That was pretty fun. So next one, we got sine squared theta minus 2 equals cosine of 2 theta. Okay. Well, once again, I don't think I want cosine squared and sine squared all in this mix here, right? So maybe there's another way. Well, all right, just in case you didn't think or you don't remember all of your three identities, let's just for now, let's throw this in here and then deal with it, okay? So let's say we didn't know our other two forms of our cosine double angle formula. So we're just like, well, I guess I got to work with this, right? There's no other way. So I'm going to throw this in here. And then I'm like, okay, well, now what? Well, I would add the sine squared over, and I get 2 sine squared theta minus 2, but I'm still stuck with this cosine squared theta. Could I replace that cosine squared theta with, say, 1 minus sine squared theta? Because cosine squared theta plus sine squared theta equals 1, and if I subtract that sine squared, I'm left with cosine squared. So yes, I can. So we got 2 sine squared theta minus 2 equals 1 minus sine squared theta. So I've used my double angle formula and then my Pythagorean identities, which I need to know anyways. So do you need to know all three of your forms of the cosine double angle formula? You don't have to if you know your Pythagorean identities, because that's how we get the other two. So now I'm going to add another one. We got 3 sine squared theta, and then minus 3 equals 0. I know that I probably, well, I guess I don't need this equal to 0, right? Because I don't have like a quadratic like this, like it's a trinomial. It's only 2 terms. So really the easiest way to solve this is with square roots. So let's bring some stuff over. I got 3 sine squared theta equals 3. Divide by 3. I get sine squared theta equals 1. And then I'll square root on both sides. So we get sine of theta equals plus or minus 1. So guys, as you're solving these things, I know I could have maybe done this a little bit cleaner here, but you're not going to know all these steps every time you do it. So it's good to be like, okay, I got some stuff going. Oh, whoop, maybe I should have kept some things over there. And you notice that stuff as you're doing the problem and how it works out, okay? So we have sine of theta equals plus or minus 1. When does sine equal 1? Well, sine equals 1 when, let's see here, theta is pi over 2, right? We're up at the top there. So pi over 2. And when does it equal negative 1? That's when it's 3 pi over 2. So that would be my bounded between 0 and 2 pi. How am I going to write my unbounded? Well, this one actually works out really nicely because these are pi apart from each other, right? So my unbounded, I could do is pi over 2 plus pi n. Easy peasy to get that unbounded solution, right? You could do pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n, but come on, man. We can handle that. We can handle that. I get this one was a little bit tougher, but we can handle that one. Try and write it in one. I think that's a nice little challenge, little goal for you. All right. Cool, man. Well, that's it. It works out. These are some fun problems, man. There are some other things that happen with double angles that we got to look out for, but I'll cover that in another video. So make sure you keep on watching and like and subscribe. Tell your friends. Tell the family. I mean, who doesn't love talking about analytic trig and solving trig at the dinner table? You know what I mean? It's a great, Thanksgiving dinner conversation talking about trig. All right. See you later.